guys, welcome back. Hi guys, welcome back. Today we're back with another live. But today we're not going to talk. It's time to learn. I know a lot of people want to apply at a company like Microsoft, but are scared. Scared of interviews, scared of lacking technical knowledge. But today at Newton School, we are giving you the opportunity to learn how an interview at Microsoft looks like. So we have Mr. Ankit Mishra, who is a software development engineer at Microsoft, and Mr. Pratik Swen, who's a Newton School alumni, joining us to make you understand how interviews work at Microsoft. But before we start, I would suggest our viewers to ask us questions in the live chat, and we'll be answering those questions very soon. So, before we without much further ado, let's start and welcome Mr. Ankit Mishra and Pratik Swen right now.
Hey, hi, this is Ankit.
Hi, Ankit.
Hi.
We'll be joined with Pratik very soon. Hey, Pratik.
Hi, Gopi. Hi.
Awesome. I won't take a lot of time from you guys, and I'll give the baton on to you. Don't want to disturb you in the interview, right?
Yeah,
Cool. Thanks, guys.
Hey, Pratik, how are you doing?
Yeah, hi Ankit. I'm fine. How are you?
Yeah, I'm good.
Yes.
So we are here for a mock interview. So the format for the interview will be I will give a brief introduction about myself, like what I'm currently doing, what are my technical skill sets, and then I would like you to introduce yourself and giving your details around like what projects you're currently working on and what are your technical expertise.
Yeah.
And then we will try to move to some problem solving. We'll try to solve a couple of problems. We'll try to first come up with an approach and then code it. And lastly, we'll take up any questions if you have for me. Okay.
Yeah, sure.
So, coming to my introduction, so as already introduced, I'm working with Microsoft. I have 8 years of experience in software development. I'm majorly into backend development and have worked extensively on distributed systems, have a good experience in Azure Cloud, building large scale applications. Okay, that's what I deal with. Can you tell about yourself?
Yeah. So I am currently working as a full stack engineer in Increment Technologies. So it's been 5 to 6 months I have joined there. So I have close to 3 years of experience in IT. So before that, I was working with TCS. So there also I have first done testing role, and after that I moved into software development role. And yes, so my current skill set is basically the full stack technologies in web development. So in front end I work with React JS, HTML, CSS, those stuffs, and in back end I work in Node.js, PostgreSQL as database, and MongoDB sometimes. Yeah. So
Okay.
yeah, other skill sets, and I love problem solving as well.
Great, good to hear. So let's quickly move to the problem solving part now. What we will do is I will share a editor with you where we both can type and write. Okay, where we both can type and see actually, and then I will write a problem there, and then we'll discuss the approach.
Sure.
I would like you to share a screen once I share the shared editor link with you. You can open the link and share your screen with me. Okay,
Yeah.
just give me a second. I'm getting it. Can you open it then?
Yes. Yeah. Yes, I'm sharing screen.
We are not able to see it. I will type the problem here. Okay. So I can read that. Yeah. This is in expression.
Yes, yes, yeah.
Given
I'm
a,
able to see.
given a string which consists of operators. Operators can be plus and minus. Right now we will deal only with these two operators. Okay. Uh, and the numbers you have to evaluate. So you have to write a function basically. You have to write a function that evaluates that expression. Okay. So I'll give an example for it. Let's say our input can be a string, which will something like this. Let's say 3 plus 7 minus 2. Okay. So you should give me an answer. So output should basically be an integer, which should look like maybe 7 plus 3, 10 minus 2, 8, right? So
Yeah,
that's what we want to solve first. Okay. Would you like me to change the editor to Java or JavaScript? What would you prefer?
Java. I will prefer Java.
Great. So yeah. So this is the problem. Do you have any questions on problem? On the code?
Um, no, no, no. Yeah.
Uh,
So the input string can start with a like, can it be first operand can come like -3 plus 7 minus 2?
let's assume for now that no, it will
Okay,
always start with a number. Let's assume.
okay, yeah, got it.
So, what will be your approach? Can you tell that first, and then we'll try to code it.
Yeah, one more thing, Ankit. So is all the numbers a single digit, or can it?
No, numbers can be of any length. So,
Okay. Yeah.
another input example input can be something like this. Maybe just give me a moment. Let's say input two can be something like this: 100 plus 121 minus 4. Something like this.
Got it.
Yeah.
Okay. So I think we can take the string and can iterate over the whole length of the string. And
Okay.
first will be finding the number. As in, suppose I will take the second input. Will the first number is 100. So until and unless we see a operand such as plus or minus, we'll be iterating and we'll be calculating the number which will be given. I mean,
Okay.
first will be 1, then 0, then 0. So this number we have to figure it out. Then when we meet a operand such as plus or minus, then
Okay.
we can like evaluate the previous expression which we had and this number with plus or minus. I think.
Okay. Okay. Uh, looks good to me. The approach looks simple, but I think implementation will be a little tricky for this approach.
Okay.
So can we quickly start implementing it?
Yeah.
I can just write a function for you and give the signature of the function.
Yeah. Sure.
And so let's assume that output will always be in the range of integer. Okay, there
Mhm.
won't be a number that which is that large that it evaluates too long. And let's say the method name is calculate expression, and your input will be a string, right? So,
Yeah.
so yes, I would like you to do this.
Okay. Can I take over?
Yeah, sure, sure. Yeah, you can type. Yeah.
So. And here. Result 10 0. So let's go for less than 12. So here I will be iterating. Suppose the first character is this one. I mean now input dot caret I, and then will be suppose we have first taken an operand as can. Okay, so can I write down another function for checking if a number is input, like input is a number? So,
Yeah, sure, you can do that. Okay.
number dash image. Dash image. And name control instance. Okay, so if number ch, if this is a number, then we can go the new number equal to sorry I think
So what happened? I mean, like, very.
yeah, actually now I typed something else, so it
Okay.
went to another screen. Yeah. I'm going to 10 plus int of and integer of ch character minus at the position of 0. Yeah, new number is this one.
Okay.
If it is operand, then operator, so it should be if new. Suppose I have taken a default one of plus.
Okay.
So if operator equal to plus, sorry. So if this is operator, then we have a result equal to result plus new number.
Okay.
Else, if operator is if minus, then result minus new number.
Okay.
And after this we'll change the operator, sorry, the new number to 0, and the operator to this one which we have got.
Okay.
And so suppose for your string 100, so first I'll be doing it as 1, then 0, then 0, it will give you 100, then it encounters a plus. So but our previous one is 100. Okay, so here it is plus 100, then it is plus 121. Okay. Result equal to result plus new number for the last
Yeah.
I'll choose it. Then I guess it should return result. Let me just go through it once.
Okay.
100, 100, operator is plus 0 plus 0 plus 100. Yeah, then new number is 0, operator is plus. Okay, then 1 to 1, then 100 plus equal. Okay. Yes, Sanket, I think this should work.
Okay.
Yeah.
Can you test it for a few of the cases? Like you just tested, I think, for input 2, right?
Yes.
Can we test it for some more inputs? Let's say,
Yeah. So suppose 1 to 1 plus
okay.
50, 50. Yeah. Minus 9. Okay. So first result. Yeah. Result is 0, and our new number is also 0, and our operator which we have the default one for now is plus. So we'll be getting inside this character ch. So the first one is 1, which will be checking with is number, so it will return true. So if it is true, then will be the new number at line number 17 will be sorry, yeah, here it will be 1 in, like the first one is 0, so 0 into 10 plus int of this one, so this will calculate to 1. So the new number as of now is with us is 1. Then it will not go into else. So after that, for the next one, which is 2, it will go to new number, and the new number will be 1 into 10, like 10 plus 2, so it is 12.
Okay.
So yeah, and after that it will be figuring to 121. So when it will like when it will encounter operator, suppose now it will encounter plus in this case. So here it will come inside this, and our default one previous to this is plus. So it will, the result will be 0 plus 121. So our result as of now is 121. And
Okay.
here our new number will change now. So our new number will change to 0, and our operator will change to plus. So it yeah, so like the
I
operator
think
will
that
be,
should work. Yeah.
yeah.
Can we check for a case where we are passing just a number? Let's say the number is 121. Just input is just 121. It's a valid input, right?
Yes, definitely.
Can we just check if it works?
Okay, so it is 121, and we have a 0, and it doesn't like it doesn't encounter this one. The number with us right now in the first iteration is completed, like it is 121. So now it will not go inside this else, and it will come outside and directly. So result we have with us is 0, and 0 plus the new number. I guess yeah, 121 should work. Yeah.
Perfect. Yeah. Yeah. I would like you to explain this line, the line number 17. You were trying to convert the character to integer. So can you
Yes.
explain me what you are trying to do here?
Yes. So new number, like I get 1 from there. So and ch is 1. So 1 minus 0. I mean the integer value of that one. Suppose we get 2, then 2 minus 0, and the integer value of 2. So it will give us 2, I guess.
Yeah. So what I mean, like line number 17, somehow you are able to convert one. Let's say you got a number 121. I like you got an input, let's say 2 as a
Yeah.
character. we're able to convert that character into an integer, right?
Into integer, yeah.
So what magic is happening at line number 17 that you're able to do it? I mean, especially the second that I've
Yes, so
highlighted.
this is the char values. I mean the ASCII values of that one. So zeros ASCII value and the ASCII value of CH, which we are just encountering. Suppose 2. So those ASCII value, like the INT value of that one, ASCII values.
Okay. And because they will always be sequential, so that's why difference will
Yeah,
be equal.
difference will give us. Yeah.
Okay, good. Okay, so I have one more question. Let's say this calculate expression will be, let's say, exposed as an API.
Okay.
Basically, you have just now implemented a method that can basically evaluate an expression, string expression. Okay, and now this is exposed as an API, right?
Okay.
What are the other things you would like to do in this method? If, let's say, you are exposing it to as a library or as an API to third party, what are the other changes, or you think you don't need to do any changes?
Yes, definitely. Like suppose in the backend we are creating this API and the user is giving any input from his end. So the changes we can do is in the response which we are sending. Suppose we will be sending a message of success, and along with this result, which will be giving to the user. Suppose it is a invalid input, as in. Suppose here we are giving +1, then 1 plus is there. Suppose the user gives 2 plus or 3 plus, then message of like wrong input given, it should be there. But like the calculation for that I have not implemented, as in we have to check somewhere here that it should be only one operator, then after that a number should come definitely. So that check I have to do. So that is one of the constraints, I guess, which we can send from backend.
So basically, you would like to do input validation, right?
Yes, input validation.
And the first line of defense probably is like you check whether the string is null or empty. And
Okay, yeah. Yes. Yeah, that one.
okay, that looks good to me. A few more questions around the same problem. Like, what will be time complexity for the solution?
It should be O of n. I mean O of n if n is the number of like length of the input.
Yeah. Okay. And okay, a quick follow-up question on against the same problem, and then because we have time, we'll then move on to a different question. Okay.
Yeah.
Let's
Yes.
say if I change this input and I say that brackets are also allowed.
Okay.
For example, your input can be something of this sort: 3 plus 7 minus 6 plus 8 and minus 2. Okay. Minus 2. Okay.
Okay.
What change will you need to make to your code to work with the brackets?
Okay. So like, do we? Yeah. So basically, it has to be solved using the BODMAS rule. Like the bracket has to be implemented first. So let's take if this is the example, then we can first like negatify all the brackets. Then if we have to do in such a way, then I guess a stack has to be there. So whenever we encounter a front bracket, I mean this one, if we encounter this one, then we'll be after that any other thing which we have, then we'll be putting all those characters into a stack until and unless we get a closing bracket. So and we'll be solving that one.
Okay.
Yeah.
What prompted you to choose this stack? Like, why would you choose this stack and not any other data structure?
Okay, so in a stack, no, not a stack. Yes, like yeah, I mean we can do it normally as well. I think a stack should be slightly over it, but yeah, we can do it normally as well. I guess yes, we can do it normally. Like first we'll be calculating, seeing if we are encountering first opening bracket, then we'll be simplifying all the results inside that. So until and unless we are getting a closing bracket. Yes, like normally we should do it.
Your stack solution is fine. I mean, there was nothing
I mean,
wrong.
yeah, I said it should be with stack, but I guess when we are doing it in stack, then it should be 6 plus a plus, then then it will be 8. Then when we are simplifying it, then we will be doing from last to first. I mean, right, 8.
Probably you will choose stack because there can be nested brackets as well, right?
Yes, nested bracket.
So you would want the last bracket, which
The
is the result for that bracket to be coming first, right? And
yes,
that's
yes.
the reason
Like it
probably
should
stack
be
would be okay, right?
one bracket. Like there are multiple brackets inside that. It should help in that case.
Yes, yes. Okay, yeah, correct, yeah. Good. Yeah. Good, Pratik. I mean, I am. We can move to the next question. I think we have enough on this problem. So yeah, let's move on to a new problem. Okay.
Yeah.
Let's say you are given a binary tree. Okay. You're familiar with trees data structure.
Yes, trees. I know. Yeah. Now we can go ahead.
Now, let's say you're given a binary tree, and your task is find the sum of all the left leaf nodes. Okay.
Okay.
So to explain you the problem, let me give you an example. It will be difficult to draw the tree, but let me try. Yeah. So let's say you have 1, 2, 3. Okay. And let's say then we have the child of 2 as 5, and let's say 7, maybe 6, and then let's say we have 4, and then we have 11. So you can see the left leaf nodes we have are 5 and 4,
And
right?
4. Okay.
So your output should be 9. You are giving me the sum of all the left, all the nodes which are leaf nodes and are the left leaf nodes. Okay.
Okay.
Another example can be maybe, we can just take a simple example like 1, 2, 3, and let's say we just have a left child of 3, which is 4. So in this case, your output should be 4, right?
Yes. Yeah.
Probably not 4. Probably you will have 4 plus 2, right? Because 2 is also a leaf node.
It
Right?
is also leaf node of left. Yeah, one left of one. Yeah.
Just one more information I would like you to provide. We won't consider root as a leaf node. If you have a single root as an input, that's basically not a left leaf node. I mean, you cannot deterministically say that it's a left leaf node. Right?
Yes. Yeah.
So your signature for this function should look something like this, or maybe int. Again, as I said, I mean, there won't be a number which is as good as which cannot fit in the integer range. And then let's call the method as sum of left leaf nodes. Okay. And your input will be node root. Your structure for the tree is simple, like we have for most of the cases, is you have int val. Okay. You have, I should write node as well here.
Last node.
Yeah, node left and node right. Okay. That's how your tree node will look like, and your input will be something like this. And you have to come up with an approach, and then maybe we'll discuss it and then we'll try to code it. Okay.
Okay. So left leaf node. Okay. Okay, so I think we should traverse it in any of the possible ways. So while traversing, we should check that if it is a left node or not. Like first we'll be checking if it is a leaf node or not, and if it is a leaf node, then it is a leaf node of a left node or not. I mean,
left leaf node or not? Yeah.
Yeah, left leaf node or not. If it is satisfying these two conditions, then I guess we should sum up. Or else we'll be checking with, or else we'll be traversing the whole tree, and I guess we'll be getting the answers from that. But
Okay. How will you determine that it's a left leaf node?
no, we can we can make a function for that for leaf nodes, as in for root dot left equal to null, or root dot left right is null, then it is a leaf node. And this is a function for leaf nodes, and we can check it for every left node which we are encountering. So
Okay.
for every left node which we are encountering, we can check that if it is satisfying the leaf node condition or not. So if it is satisfying, we can
Looks good to me. The only challenge here is how will you identify that whether it's a left node or not?
okay. So I mean, we can traverse in the normal way in pre-order or any traversal method. And when we're encountering the left node, we can only we can only put the condition which we are writing for leaf node on the left node. So on the left, while we are checking it for left nodes, we can only put that condition on that left node. So there on we can check that if it is a left leaf node or not. This,
Do you think it will work? Because I mean, if you're saying that we will traverse, let's try to
okay.
let's try to run it on one of the examples. So let's say you are doing a pre-order for this, right?
Yeah.
So when you're doing pre-order, you will move to left for 2, right? And then
Yes,
you
for
will
two.
again move 5, right? And
Yes.
you will find that it's I mean, how will you at note 5, how will you know that whether you have come?
So when we'll be going from 1 to 2, then we'll be checking for 2 that if
Yeah.
yeah. So first for 1, let's check that
Pratik,
one's left, which is 2.
I lost your voice for a second.
Just one.
Can you repeat again?
Is it audible?
Yeah, better now. Yeah, yeah.
Yeah. So we'll be first checking for from first, like for 1, we'll be checking if its leaf node, which is 2, is a leaf node or not.
Correct.
So, but it is not. Then we'll be checking for 2 if its left node, which is 5, is a leaf node or not. So it will be a leaf node 5. So we'll be summing up this 5. Then we'll go to 2's right 6, but it is right node. As it is right node, we won't implement that leaf node condition here. So
So
and
Pratik, my only question is like once you reach the node 2, let's say you have come to node 2, okay? I mean, in your function, basically, you will have one node at at any point of time. You will have access to
yeah,
one node or
yes,
its
yes,
parent. You won't have access to parents, right?
yeah, yes,
Correct.
but yeah,
So now you are at node 2,
yeah,
right? You can figure out that whether it's a leaf node or not. That's correct. I mean, you can just figure out that it has a child or not, and you can figure out whether it's leaf node or not.
okay.
How will you figure out that whether it is a left child or not?
Okay, so we can pass the way we do it recursively, as in for 1, I am talking for 1, then I will check that for one's left, which is 2, I will
Okay.
pass that one. This one's left, which is 2, I will pass this one to my condition. I mean
Okay.
the condition which is checking if it is leaf or not.
Yeah.
So 2 will be
Makes
going.
makes
So
sense.
and for
Yeah. This makes sense. Basically, you can pass something from parent to the child, which can basically give a hint to the child that whether it's a left node or not,
left
right?
and right.
Yeah. So yeah, looks good to me. What will be time complexity for this solution?
As it is traveling the whole tree, I guess O of n will be yeah there.
Okay. Yeah. So can we go with the implementation now?
Yes, I guess, yeah. First, let me just do. Root. So if root is null. So first, if this is null, then it is false. I mean, it is not there. Then if root dot left equal to null and root dot right equal to null, then it is returning true. And suppose null, if for any other value it is encountering, it should give return false.
Perfect.
Okay, so here now we'll be getting no root and sum, let's take for now is 0, and we'll be returning some sum. Okay, so if root is not equal to null, we'll be going inside that. If root is not equal to null, which is 1, we'll be checking inside this. First we'll check if is leaf, if is leaf root dot left. So if I'll check that, if that is satisfying, then sum equal to sum plus root dot left dot val. If it is not, if it is not leaf node, then if it is not leaf node, then we'll go as in recursively. I mean sum equal to sum plus the answer which we'll be getting from that one. So here we have to do it recursively. Root dot left. Okay. And it will go to 2. Then from 2 it is it will check for 5. Okay, and one more thing. Here we'll be doing some. Okay, the right nodes can also have left node. Sum equal to sum plus sum equal to sum plus sum of left nodes root dot right.
Probably you would also, I mean, this is just, I mean, I'm not sure if the solution that you're writing, if you have completely figured out the approach for it, that whether it will work or not. So
Okay.
there can be one thing which you can do, which probably will ease out a lot of checks for you. Okay.
Okay.
And that one thing can be, is it possible that we pass some information from the parent, okay,
Mm-hmm.
that the next node is a left child or the right child? Can we pass such information? And then basically each node can calculate that whether it's a leaf node or not. And because there is the information from the parent that it's a left child, okay, so it can just add
Okay.
to the sum, otherwise it just doesn't add anything.
Okay. So passing as in you were saying for parameter wise. I mean for here we can pass something as 1 or 0.
You can, I mean, like I mean, you can have, let's say, a utility function, okay,
Okay.
which is sum of left leaf nodes or
Okay.
sum of left leaf nodes utility. take certain parameter. I mean, that's just one of the suggestions. I mean, if you're confident that the way you are going will solve it, then go ahead. I mean, there's no problem with it. Yeah.
Okay, got it.
What I
Got your.
yeah. Yeah.
Okay. Okay, so like one of this solution which I think is this one. I mean, I have nothing more to do in this one, but
Okay. So this is complete. Do you think this is the complete solution?
yeah,
then,
yeah.
Then we can basically dry run it. I mean, that's it's not necessary that we go with any other.
Yeah, the sum one which you are saying.
Yeah. I mean, the one which you have currently.
Yes.
Yeah.
Okay. Let me just write something. So for every node which it is encountering, we'll be checking there only, right? If it is leaf or leaf from the parent, and if root dot left. I'll be writing after that. Let me just.
Yeah. Take your time.
I mean, for this time, let's take anti-sum is sum.
Are you trying to give another implementation for the same problem, or?
Yes. Like another reason I am trying to do that sum, like how to do it for the way you approached, as in.
No, that's okay. I mean, approach.
Okay.
If your approach solves the problem, then we don't need.
Okay. Yeah, fine. I think this will work, like.
It
Yeah.
should work for all the cases you're saying, right?
Yeah.
Can we just check that if it will work for all the cases?
Okay. Yeah. So the let's check for first this one 1 2 3 4.
Sure. Yeah.
Okay. So here like the sum is first. Let's say assume as 0. And yeah, so root is not equal to null. So if it is not null, which is 1 is not null, then we'll be checking if is leaf root dot left. Root dot left as in 1's left is 2. So we'll be checking if it is leaf or not. So it will basically give you a true value. So we'll be summing up like sum equal to sum plus root dot left dot val. Then this sum will be a 2. Then so here sum equal to sum plus sum of like now we'll be going to the right side, which is basically 3 for this one. So for 3 now it will going here. For 3 it is okay. So 3 yeah, for 3 I think the sum should be outside. I mean it will every time it will give it will okay, and that will be figuring out. So now for 3 it will check if it is 3 is a root, which is 4 is sorry.
Let's say.
Yeah, I missed one case actually. Yeah, once right, which is 3. If it is a leaf or not, so it will give you basically false. So no need to sum up anything. Then it will go to this condition. I mean, sum equal to sum plus sum of left node root of left root dot left. So now it will check for 4. So for 4, then again it will give you is leaf will give you a true value. Then we'll be summing up that one. So 2 plus 4. Then I guess it will be 6.
Okay, let's try to stop at the place where we go to the right node. Okay. So we reached. That's okay. We got to the sum equals to 2, right?
Okay.
And once we have got the sum equals to 2, then we start iterating towards the right side of the root. Correct?
Yeah.
And then we move to 3. Okay, because you will pass root dot right. Correct?
Okay.
And then basically what you're trying to do is you will find is leaf. Basically, you will find that root is not null.
Not null. Yeah.
and you will find that it's not
Three is not
leaf node.
null. Yeah.
3 is not
Not
a leaf node,
leaf.
right?
Yeah. So
Correct.
line,
Then
yeah. So
yeah.
basically line number 30 will be implementing after that. Like its left node will be traversed then. Three is left node,
So
which
yeah, yeah. So what about the left side of it? I mean, let's say we had something like this. After 2, we had another left child, which is 5. Will your solution work for that case as well?
where do you want the node exactly? Can you just show me? Two's left, as in
Let's,
here.
let's say there is a left child of 2 as well, and let's number it 5. Yeah.
Yeah. So for here, yes, like from the starting when you will be checking it. I mean, for two, then it will not give you a left node as true. Then it will be
Correct.
false only. Then after that, when you'll be checking for again is leaf root dot left. This will be then the condition. Sum of left leaf nodes root dot left. Then it will be coming to 5. So here it will check for check if it is leaf node or not. Then I guess it will be giving 5 here. Then again 2 is right, which is null. So no, nothing to worry about that case. I guess yeah,
Okay.
I think it should work for that.
Okay. Leaf. So what you're doing is just checking that. It's leaf. My only concern else block is leaf root. Okay, okay, you are doing this piece, and otherwise you are calling this else. Okay. Okay. Mhm. Why the sum line number 32, right? Why this line number 32 shouldn't be in the else block that you wrote, and why it should be out of that else block?
If leaf root dot left. So this condition is only for the root dot left condition, as in if it is root dot left is, I mean for a node, particular node, if it is left node, I mean for one, let's check for one. So one
Okay.
left will be first checking if it is leaf or node. If it is not left, if it is not leaf, then we'll be going to left of this node. I mean for two's
Okay.
left, and this is like totally the right side things.
Okay. Okay.
Do
Okay.
it inside that
What about if we have a left child of in the example one? Let's say we have a left child of 6.
okay, here, right?
Yeah, in the example one, basically. Let's just
Just 1 minute. I think I have this one.
I think you will miss out on that case.
8, right? Here.
Yeah, yeah.
So we'll be checking for I guess the first will be 1, then 2, which will be giving you false. Then it will check for 5, which will be giving true. So 5 will be counted. Then for 2's right, it will check here. So
Okay.
it will check for 6, which is false. Then for then it will take the whole tree of 6, as in then 6 right, 6 left, 8. Then 8 will also taken into consideration.
Okay, okay, makes sense, makes sense. Yeah, yeah, makes sense. I thought probably you might miss on the
Okay,
left of the. Yeah,
doubles.
looks good to me. Yeah. Anything you would like to change in this code? Maybe I mean, like we discussed in the last example, if you have to expose it, let's say as an API or as a library, anything you would like to change in it?
Okay. Um, like here the constraints I guess I have given for the null one,
Okay.
and
Mhm.
mm, okay, like I don't think any major change would be required, but
Okay.
yes, I don't think any major change would be required except for the any validation issues or something.
That's okay. I mean, you have already done the validation on the root part, so that looks good to me. That should be fine. Okay.
Okay.
One other question I have is, will your is leave function be a private or a method in the class, or will it be a public method?
No, it should be private, as in it should not expose it to any other thing. It should be okay for class. You are saying, then inside that package, if it is there, so it should be public one, like any other class which is just checking for leaf nodes. We can check for that as well. Not just this function. We can check for any other function as well.
But I would recommend it to be private probably, because what we want to expose is currently we just want to expose the functionality of calculating left leaf nodes, right? We don't want to expose functionality. So let's assume that we just want to do that. Then in that case, it will be private, correct?
Okay. Yeah. Yes.
Yeah. So let's say if this is a private method, do we need to do this null check here at the line number 39 and 41?
Line number 39. Okay. Null check. And 42, right? No, 41. Okay.
Between line number 39
Okay,
to
okay,
41.
okay. Yeah. I mean, yes, we have to do it, right? Like for every, even if it is private, even if like if it is private, then it will check for every node of the tree, right? So,
will you ever pass a null node here, or do you think you can pass a null node here?
okay, from the parent function.
Yeah, from the parent function.
Okay, like I have never used this in private, but like let me just take a look. I think we can do it, but like I have never use case this one, but I think we can do it. Like I don't know exactly.
No. So my question is
Yes, yes.
whether it is needed or not. I mean, I'm good with your approach.
Yes, like it should like according to me, it should traverse the whole tree. So even if we are checking for some other leaves which are not like if it is not null, then it should be inside that. If you would,
okay, probably. I mean, it's needed. You have done it correctly. Okay, that's
okay.
not. I mean, it's not that we can remove it. I just wanted to know where do you see it coming into picture?
Okay.
Are you actually
I guess
passing
null for all the null, then for we are checking if for fives left. If it is for fives left, then it is a null. I mean, then it should give false in that case here.
Yeah, probably line number 27, and wherever you're passing, I mean,
yeah.
passing root dot left or root dot right to the leaf, and you're checking null condition for root. So it's possible that left and right can be null. Yeah, perfect, man. I'm done from my side. I think I'm done from the questions perspective. Do you have any questions for me?
No, not actually.
Okay. Before we move to the next section, I hand over the control to Gopi. I wanted to give certain feedbacks, which may be relevant for you and also for the people who are watching this. So, few things to note down, which were very good from your side was one, you making sure that you understand the problem and clearing all the assumptions. You're not making any assumptions. That's something very important. Even if you know the problem from before, let's say you have read that problem before and you have seen it somewhere, but it's always good to not make any assumptions. Example, in the problem one that I talked to Pratik, he asked me, is it possible that we can have an operator before a number? He asked me if there can be a case where we have an invalid expression. Okay, so it's always good not to make any assumption and make sure that you understand that what input you will be dealing with and what kind of I mean, just make sure that you understand the problem well. Okay, so that's a very good part, Pratik, that from your end. Okay, second thing which I really liked is which is a unsaid rule basically in any interview, right? Is how good you are writing your code. I mean, it's not just about implementing the functionality, how readable your code is, how modularized your code is. Maybe it's not a functional requirement at that point of time, But for an interviewer, it's always good, no? I mean, if he's seeing the problem, if he's reading your problem, he should be able to just make out what you're doing. So I liked your approach that you decoupled your functions. For example, the check for just a simple check like is number, you were making it as a separate check, and then you are implementing the code. And similarly, I mean, like as leaf node, it's a very small check, but it's making your code more readable. Okay, that's another good thing about your solution. Okay. Uh, I mean, coming to the problem and solution, it's always a matter of how well you have practiced and how good you are at your DSA, right? So I won't comment much on that. You did really well on that part. You were able to come up with a optimized solution for both the problems. So you did good well on that part. But again, I don't have much of a feedback over that because it always comes with practice. It's not something which I can give a feedback that you do this and you can become better. So you did well. Probably you have practiced well. Okay. And things probably which as I mean you did I mean most of the part you did so well that I really have a very few critical comments for you, but just for the sake of it, if I have to give, then uh, when you solve a problem, right, it's okay. I mean, we are solving a DSA problem and we are writing a method which is going to solve the given problem statement given in the interview. But it's always good to think on a wider perspective, the perspective of, I mean, no one basically will ask you. I mean, whenever you're working in an organization, probably you will never write a function just in a silo which is doing calculate expression bar, unless I'm writing some unit test cases and there you need it. But most often you will write a function which is going to be used by someone else, which is going to be exposed as an API or as a library or as an interface going to be used by someone else. Okay, so it's always good to think on those directions that you are taking care of those aspects, and it's always a plus point. Okay, so you did well, Pratik, from my end, I think, and that's all I could say. Uh, I think we are done with this interview, given you don't have much questions for me. I will hand over the control to Gopi now. Yeah.
Kudos, Pratik.
Thanks, Gopi.
Awesome. So, Ankit, we have a few questions here in the comments. Himanshu Gupta asks, in 10 months' time, is it enough to prepare for Microsoft, considering he has 10 months?
I would say, I mean, I've been asked this question a couple of times, like what is the tenure to prepare for, let's say, Microsoft or any of the product companies people talk about, and I say there's no definite answer to it. The answer is where you currently stand, right? You have to self-evaluate where you are currently. If you are starting from scratch and you have not been familiar with any DSA thing, right? Then it will again depend on what has been your problem solving experience before. Maybe you are from a maths background and you have done a lot of mathematical calculations and you are able to catch up on DSA and mathematics around it, right? Probably it will take you a smaller time. But let's say someone is completely new to problem solving as well and coming to learn DSA from scratch, it might take 2 years as well, right? So it's an iterative approach. What you can do is you can start preparing and self-evaluate through mock interviews or through going through some coding questions, interview questions, and checking where you stand. So there is actually no definite answer for it. But for an average CS background person who has, let's say, has taken a 4-year computer science or information technology course, have some experience with DSA and have an average aptitude, I would say 10 months is good enough time if you have given dedication to it. Yeah.
Okay. And Himanshu again has a follow-up question. He's wondering how to clear his basics in less time.
I mean, see, Himanshu, I mean, frankly speaking, I will not give answers which might sound very good because there's no shortcut. That's what I would say. You have to practice and you have to practice. Probably you can reduce on time by working, let's say, instead of 6 hours, you work 12 hours a day. And instead of 10 months, you can complete it in 5 months. But there's no shortcut, actually. You have to learn the basics. So my approach towards DSA is, learn the basic data structures implementation. If you are new to it, try implementing a linked list add, linked list delete, try implementing a simple graph problem. Okay, just get familiarized with all the data structures, and then jump into the problems on different coding sites you have. Okay, and that's how you clear it. And again, it will depend on how much your time you put in, how quickly you can come to that level.
Right. We just got another question. Divyanshu Srivastava is asking, sir, as DSA has no upper limit in the upper bound, so till what level can I go for Microsoft?
So yeah, I mean, it's a good question actually. It's a very good question actually. So see, I would say there are two different things: competitive programming and interviews are two different things. Okay, there's no upper bound when you are looking to excel in competitive programming. Okay, but when it comes to interviews are a little different from competitive programming. It gives you an edge if you are good at competitive programming, but interviews have different requirements. Okay, so someone who has a good understanding about DSA and has solved some amount of problem, okay, uh, makes you reach to that level where you can clear the interview. And there are some non-functional requirements that interviews add to, which are not there in competitive programming. For example, how good your communication skills are, how well you are talking when you are solving the problem. You should be able to explain your solution to the interviewer. Okay, probably, I mean, you solved something really well, and even the interviewer didn't had that approach in his mind. So you have to explain the solution and let him understand what you are trying to solve, right? So that's what my answer is. So yeah, I hope that answers.
Okay, cool. It was great talking to both of you, and I hope that our viewers have also enjoyed and learned something from you guys today. Thank you for joining us, and we'll be keeping in touch.
Yeah.
Yeah, thanks.
Thank you.